In the 90s, I was working on a project called Ask Eric. It was a service that would answer questions of educators and policymakers online. It was early days of the web, well before Google, or Facebook, or Amazon. Yet even then, we would regularly get questions about artificial intelligence. People would ask, can't machines answer these questions? My boss at the time, his answer was great. We'll use natural intelligence until artificial intelligence catches up. A quarter of a century later, artificial intelligence has done some significant catching up. From search engines, to conversational digital assistants, to machine learning embedded in photo apps to identify faces and places, the progress of AI has been breathtaking. The last 10 years of progress is particularly impressive, particularly when you realize that AI has been a quest of computer scientists since, well, before there was computer science. Today, the larger conversation of AI tend to be either utopian, AI will improve medicine, reduce accidents, and decrease global energy use, or decidedly dystopian. It will destroy jobs, privacy, freedom. AI has also become a bit of a marketing term. Soon, I fear we'll be eating cereals fortified with AI. The hype and real progress have merged into a bit of a jumbled mess that overall can lead to a sort of awe and inaction. Awe in that many of us in the library, and frankly particularly in the public library community, may feel the details are over our head. AI is a game for Google. Inaction because the topic seems just so big. What role is there for libraries when these tools are being created by trillion-dollar industries? True story. The same day that my dean came in and asked me about the possibility of creating a degree in data science and AI, MIT announced a billion-dollar plan to create an AI college. I don't think my dean appreciated when I asked if I would have $1 billion to work with. Look, I've found these reactions, awe and inaction, are often a result of muddled vocabulary. So, for my contribution to today's agenda, I'd like to briefly break the conversation down into more precise and actionable concepts. My focus here will be on the contribution of public libraries, but I believe the concepts are not only relevant to other public sector organizations, but can only be truly implemented with partners across the public sector and, in fact, across industries. So, rather than just thinking of AI as a big amorphous capability, I ask you to think about 3 interlocking layers: data, algorithms, and machine learning. We'll come back to that in a second. Ready access to masses of data have led to high-impact algorithms and increasingly to machine learning and black box, deep learning systems. If we librarians do not seek to have a positive impact at each of these levels, well, to be blunt, I would argue that not only are we not doing our job, we're putting our communities in danger. So let's begin with data. The first thing that gets thrown into the AI bucket is the idea of data, or big data. From data science to analytics, there's a global uptick in the generation and collection of data. With the advent of always connected digital network devices, read smartphones, in the pockets of global citizens, data has become a new type of raw resource. And when I say global, I mean it. In 2010, the United Nations reported that there are far more people in the world that have access to cell phones than to a toilet. With this connectivity, most in society have simply accepted that one of the costs of being connected is sharing data. Sharing it with the carrier and sharing it with the company who wrote the phone software. Apple and Google probably know right now where you are, who you're with, and if you use Siri or Google Assistant, they are primed to be listening to what you might be saying right now. No, I mean literally, right now. The phone thing probably doesn't surprise you, but what about the road you use to get in today? When governments build or repave roads, there's a good likelihood they are embedding sensors into that road. Why? Well, one reason is to save the environment and money in northern climates. How? In the winter, rather than just laying down salt and chemicals on every mile of road, smart sensors can pinpoint where the ice melt is needed, and therefore reduce the application of costly chemicals. Sensors in the road are also used to determine the amount of traffic on that road, when to change signal lights, how to collect tolls, and to check for wear and tear. Now, add to this data generation by cars on the road, digital radio, GPS, increasingly autonomous driving, and the data begins to add up. In fact, by one estimate, in a few years, each mile of highway here in the US will generate a gigabyte of data an hour. As there are 3.5 million miles of highways in the US, that would be 3.3 petabytes of data per hour, or 28 exabytes per year. Now, just in case you're wondering what an exabyte looks like, 5 exabyte is enough to hold all words ever spoken by humans from prehistory to about 1995. Now imagine over 5 times that amount just in asphalt. Now that may seem overwhelming, but at the data layer, there is a lot of need and space for libraries to participate. The questions to ask and develop answers to are familiar. Who has access to that data? How is that data stored? And how do you find anything in that exabyte haystack? How do we make people aware of the data they may be sharing? How do we advocate for effective regulation to protect citizens? I argue that public libraries should be stewards of public data. Libraries have a very long history of data stewardship that includes respect for privacy and seeking equitable access to information. If we are going to allow our governments and our businesses to harvest data, then we need to ensure our communities have a strong say in what happens to that data and in trust in those who make those decisions. Right now, libraries have a stronger level of trust than Apple, Google, Facebook, and let's face it, most elected governments. The accumulation of data in and of itself is not particularly alarming. As libraries have shown over and over again, having a bunch of stuff means nothing if you don't have systems to find and use it. This takes us to our second layer of concern in AI, algorithms. Companies and governments alike are using massive computing power to sort through data, much of it identifiable to a single individual. And then these folks are making some pretty astounding decisions. Decisions like which ad to show you, or what credit limit to set on your credit card, to what news you see, and even what health care you can receive. In our most liberal democracies, software is used to influence elections and who gets interviewed for jobs. Charles Duhigg, author of The Power of Habit, tells the story of an angry father who storms into a department store to confront a store manager. It seems the store has been sending his 16-year-old daughter a huge number of coupons for pregnancy-related items, diapers, baby lotions, and such. The father asked the manager if the store is trying to encourage his girl to get pregnant. The manager apologizes to the man and assures him the store will stop immediately. A few days later, out of a concern for service, the manager calls the father, only to find out that the daughter was indeed pregnant, and the store knew it before she told her father. What's remarkable in this story is that the store knew about the pregnancy without the girl ever actually telling a soul. The store determined her condition from looking at what product she was buying, activity on a store credit card, and in crunching through huge amounts of data. If we update this story for today from a few years ago, we could add to her search history, online shopping habits, and even her shopping at other physical stores. It is now common practice to use online tracking, Wi-Fi connection history, and unique data identifiers to merge data across a person's entire life and feed them into software algorithms that dictate the information and opportunities those folks are presented with. In her book, Weapons of Math Destruction, Kathy O'Neill documents story after story of data mining and algorithms that have massive effects in people's lives, even when they show clear biases and faults. She describes investment algorithms that not only missed the coming financial crisis of 2008, but actually contributed to it. Models that increased student debt, prison time for minorities, and blackballed those with mental health challenges from getting jobs. The recurring theme in her work is that these systems are normally put in place with the best of intentions. And here we see the key issue in the use of software to crunch massive data and make decisions on commerce, healthcare, credit, and even jail sentences. That issue lies in the assumptions that those who use the software are making, often very dubious and downright dangerous assumptions. Assumptions such as algorithms are objective, and that data collection is somehow a neutral act, or even that everything can be represented in a quantitative way, including, by the way, culture and the benefit a person makes to society. What role is there for librarians, curators, and academics here? The answer on the surface is about the same as our discussion of data: education, awareness, voice, and regulation. However, we must be very aware of the nature of our voices. For too long, librarians saw ourselves as neutral actors. We collected, described, and provided materials, believing that these acts were either without bias or that those biases were controllable. In collecting, we took it all, except for books that were self-published or from sources we didn't like. In cataloging, we relied heavily on literary warrant and the language of the community, often ignoring that we only saw the dominant voices of that community. Our services were for all during our open hours for those who could travel to our buildings. As a profession, we're now waking up to the fact that we are a product of our cultures, good and bad. We understand that the choices we make in everything from collections to programs are just that, choices. Now, our choices may be guided by best practice or even enforced by law, but ultimately they are human choices in a material world where resource decisions must be made. So as a library, we are not asking to be neutral arbiters of data collection and uses. We're seeking to improve society through data and algorithms. That means we have a point of view. We have a definition of what improve means. However, the biases we bring, or more precisely, the principles we bring to the Googles and Facebooks of the world, is a strong voice that advocates for transparency, privacy, the common good, and the need for a durable memory. We recognize that biases exist even if we can't always identify what they are, and so we require diversity and inclusive voices in our work. In this act, we're not simply advocates, we are activists, a missionary corps of professionals equipping our communities to fight for their interests. And this brings us to the last layer. The layer most purists would say is the true artificial intelligence development. The use of software techniques to enable machine learning, and especially the more specific deep learning. That is, software that allows the creation of algorithms and procedures without human intervention. With techniques like neural nets, Bayesian predictors, Markov models, and deep adversarial networks, software sorts through piles and piles of data, seeking patterns and predictive power. An example of machine learning systems in action would be feeding a system a number of prepared examples, say hundreds of MRI scans that are coded for signs of breast cancer. The software builds models over and over again until that software can reproduce the results without the prepared examples. The trained system is then set upon piles of data using their new internally developed models. With the wide availability of massive data, newer deep learning techniques do away with the coding and go straight to iterative learning. Where machine learning used hundreds of coded examples, deep learning software sets free on millions and millions of examples with no coded examples, potentially improving the results and eliminating the labor-intensive teaching or training phase. When this works well, it can be more accurate than humans doing the same task. Think about it. Billions of operations per second finding pixel by pixel details humans could never see. And they can do it millions and billions of times, never tiring, never getting distracted. In these AI systems, there are two issues that librarians need to respond to. The first is that these machine-generated algorithms are only as good as the data they are fed. MRIs are one thing, credit risks are quite another. Just as with our human-generated algorithm, these systems are very sensitive to the data they work with. For example, a maker of bathroom fixtures sold an AI-enhanced soap dispenser. The new dispenser reduced waste because it was extremely accurate in knowing if human hands were under the dispenser, or if, say, a suitcase at an airport were under it. Extremely accurate, so long as the hands belonged to a white person. The system could not recognize darker skin tones. Why? Was it a racist machine? Well, not in and of itself. It turns out it had been trained only on images of Caucasian hands. We see example after example of machine learning systems that exhibit our worst unconscious biases. Chatbots that can be hijacked by racists through Twitter. Job screening software that kicks out non-Western names. Image classifiers labeling images of black people as gorillas. However, bad data ruining a system is nothing new. If you've had about 10 seconds of work migrating integrated library systems, you know that all too well. The real issue here is that the models developed through deep learning are impenetrable. That MRI example, looking for breast cancer, the programmers can tell you if the system detected cancer, even the confidence the software has in its prediction. The programmer can't tell you how it arrived at that decision, and that's a problem. All those weapons of math destruction Cathy O'Neil described can be audited. We can pick apart the results and look for biases and error. In deep learning, everything works well until an airplane crashes to the ground or an autonomous car goes off the road. So, what are we to do? This is tricky. There can be no doubt that data analytics, algorithms, and taking advantage of massive data and AI have provided librarians and society with great advantages. Look no further in how Google has become one of the librarian's greatest tools because it provides not only the ability to search through trillions of web pages in milliseconds, but often serves as a digital document delivery service undreamed of 25 years ago when I was working on Ask Eric. And yet, we still need that natural intelligence my boss, Mike Eisenberg, by the way, talked about. Our communities and our society needs a voice to ensure the data being used is representative of all of a community, not just the dominant voice or the most monetizable. Our communities need support, understanding, and organizing to ensure that the true social costs of AI are evaluated, not simply the benefits. Now, this may sound like our job is to be the critic or even the Luddite holding back progress, but that's not what we need. Librarians need to become well-versed in these technologies and participate in their development, not simply dismiss them or hamper them. We must not only demonstrate flaws where they exist, but be ready to offer up solutions. Solutions that are grounded in our values and in the communities we serve. We need to know the difference between facial recognition systems and facial recognition systems that are used to track refugees. We need to know the difference between systems that filter through terabytes of data and systems that create filter bubbles that reinforce prejudice and extremism. And today is a great first step to honoring that responsibility. Thank you, and I look forward to the conversations to come.